Okay, so in section 3.3, we're going to do problem number 11. And problem number 11 says, identify the open intervals on which the function is increasing or decreasing. So, first, what we have to do is determine where the function, our function in this case is y equals x times the square root of 16 minus x squared, is defined and continuous, and we'll answer the question later of where it's also differentiable. So, where is it defined and continuous? Well, it will be defined wherever we don't divide by 0 or take the square root of a negative number. So, we can answer where this is going to be a negative number, or we're going to take a square root of a negative number, whenever 16 minus x squared is going to be less than 0. So we can add 16 on both sides, or x squared on both sides there, and take the square root of both sides. So if x is greater than 4, and remember that we're taking the square root, so if also x is less than negative 4, we are going to get negative numbers when we put it into 16 minus x squared. So outside of this interval, our function is not defined. So it's only defined from between 4 and negative 4. Negative 4 and 4. Right? We can actually put in the values of negative 4 and 4 themselves, because that will just end up being 0, and square root of 0 is still just 0. So our function is continuous on negative 4 to 4, because square root of this function is going to be defined, and it will be defined at all points between negative 4 and 4. So now we know what interval that we should be examining. So the next spot is to find where the derivatives are and whether or not they exist on this interval where the function is continuous. So the derivative of our function being x times the square root of 16 minus x squared, so we can use the product rule and the chain rule to figure out this derivative. So our first factor for the product rule is x. Our second factor is square root of 16 minus x squared. So we'll hold x constant first. We will bring down the 1/2 power of the square root of 16 minus x squared and reduce this power by 1, so we will be negative 1/2, and we also, by the chain rule, have to find out what the derivative of this inner function is, and that is going to be derivative of 16 is 0, derivative of minus x squared is negative 2x. Don't forget that negative. Then the second part of our product rule will be to take the derivative of x, which is 1, and multiply that by 16 minus x squared. Let's simplify this first term out a little bit. So we have negative 2, there are 2 x's in the top there, so that's squared. Let's, by the fact that I have a negative exponent right here, send the base of that exponent down into the numerator, so that's 2, 16 minus x squared. Sorry, I'm writing on an angle because I tilted my little thing a little bit, so sorry about that. So this 2 will cancel out with that, and plus square root of 16 minus x squared. Okay. Let me write myself a little bit here. Okay. Y prime equals negative x squared over and this should be to a 1/2 power there, square root of 16 minus x squared plus square root of 16 minus x squared. So I get a problem at, so there is my derivative will not be defined at 4, negative 4, and 4. So these, my y prime does not exist at negative 4 and 4, even though it's defined in my function, my original function, because I get division by 0 when I try to put those values of x into y prime. So these form at least 2 critical points. So these are going to be at least 2 of my critical points, negative 4 and 4. Okay, so what else? Well, wherever y prime is equal to 0 for my critical points. And that will be wherever negative x squared over square root of 16 minus x squared plus, I'm starting to do that thing again, 16 minus x squared equals 0. So to solve this, I'll add this quantity to both sides, so I get square root of 16 minus x squared will be equal to x squared over square root of 16 minus x squared. When I multiply both sides by the square root of 16 minus x squared, I get 16 minus x squared equals x squared. So therefore, when I add x squared to both sides, I'll get 16 equals x squared. So therefore, x will equal the square, 2x squared, the square root of 8. So these, remember, when you take a square root, it could be either plus or minus. So there are 3 2's that make up 8, so this is the same thing as 2 square root 2 plus or minus. These are my other critical points. So I have a critical point at negative 4. I have a critical point at negative square root 2 times 2. And I know that negative square root 2 times the square root 2 is going to be a negative, so it's relative to 0. It's more than 0. I also know that it is going to be more than negative 4 because square root 2 is less than 4, right? So that is going to be my one critical point. My next critical point is going to be 2 square root 2, and then finally 4. Okay? So I need to, if I want to determine the intervals on which this is going to be increasing or decreasing, usually I would say that you need to take an interval or a test point of the interval that is less than negative 4, but our function isn't defined, so why not defined for values of x which are less than negative 4. So our first interval is going to be, our first open interval is going to be negative 4 to negative 2 square root 2. Our next interval is going to be from negative 2 square root 2 to positive 2 square root 2. And our last interval will be 2 square root 2 to 4. So here's my 3 intervals. Here, here, and here. We want to choose a test point from each one of these intervals, and the sign of that test point will tell me whether or not the function is increasing or decreasing on that interval. Because it has to be all of either increasing or all decreasing between critical points. My critical points being negative 4, negative 2 square root 2, 2 square root 2, and 4. So, let's see. What is 2 square root 2 approximately? it is roughly 2.8. So I could choose a test point of 3, negative 3. For this interval, I can use a test point of 0. For this interval, I can use a test point of 3. These test points go back into your derivative. So y prime at x equal to negative 3, y prime will be equal to negative of a negative 3 squared divided by the square root of 16 minus negative 3 quantity squared plus the square root of 16 minus negative 3 quantity squared. Okay, what I'm going to do is I'm going to go to my graphing calculator. I'm going to hit the y equals button. I'm going to put it in, and I'm going to say, let's see, where is it? Negative x squared divided by the square root of 16 minus x squared. Remembering that I have to enclose right after the square root symbol beginning parenthesis and end parenthesis around 16 minus x squared. And then I'm going to add the square root of quantity of 16 minus x squared. Sorry I can't provide you that in a visual form, but follow along with me if you can. And then I am going to go to my table, select my table set. I will have my independent variable as ask. I will go to my table and I will put in some of these values. Right? My first test point is negative 3, and I get out a value of negative 0.755. So this is going to be negative. I put in a value of 0, I get 4, so that is going to be positive. I put in a value of 3, I get negative. So this tells me that the function is decreasing. So let's write out some of these intervals. On negative 4 to negative 2 square root 2, y is decreasing. On negative 2 square root 2 to 2 square root 2, y is increasing. And from 2 square root 2 to 4, y is decreasing again. So if I were to plot this guy using some kind of graphing utility, I use gcalc from gcalc.org and I hit enter there, I see that my function is increasing all the way up until negative 2.88, so that's good. And then I have a little horizontal tangent line right here. My function is increasing to 2 square root 2, and then it is decreasing. And then it is not defined outside that interval. So that's good. That is problem number 11.